Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th, our ongoing chapter, work, energy, and power. Today we are entering into the second session. So in last class, last Friday, we have started this chapter and we discussed about the complete about work. So we discussed about what is work, or when you said work is done, and what are the types of works, right? Types of work done. So we have clear picture about what is work done, or when you said a work is done. For example, if you are applying some force on a body and body is displacing, then only you can call it as work is done. That is force into displacement. So work done is, the work is said to be done if the body displaces along the direction of force. The force may be either push or pull, no matter. Either you are pushing or pulling, the body changes the position or body displaces, then only you can say work is said to be done. If not, there is no work is done. But there are some conditions are there for work done. That is, the work done may be positive, right? Work done may be positive, just a minute. Or work done may be negative, either positive or negative or zero. Zero work done also possible. Means whenever body displaces along the direction of force, either you are pulling the door or pushing the door, or pulling any object or pushing any object, the body will move along the direction of force. Such force is called, such work done is called positive work done. Suppose when you are lifting the object from the ground, as you all know that gravitational force acts in the downward direction, but we are moving the body upward direction against the gravitational force. So the work done against the force is called negative force. The work done against the force means the direction of force and work done are different. And out of these two, work done depends on force and displacement. You are applying a force on a body, but there is no displacement. Then we can say work done is zero. Right. So like that, there are three. The work done can be classified into either positive work done or negative work done or zero work done. So about this, we have seen the video also, explanation of work done. So totally, you can see that here also synopsis 1. So you have seen the introduction of work. So when you say work is done, so that work done is measured by in joule or erg. Joule is the SI unit of work done, whereas erg is the CGS unit. So when you see work done against the gravities comes a negative work done, okay, positive work done, negative work done, and zero work done are the three types of works, right? So you are clear. When a body displaces along the direction of force, suppose you are sitting on dining table, you are having your breakfast, you can find so many items in front of you. They won't come themselves to you. What you have to do? You have to apply force. You have to pull the vessel towards you. So when you are pulling the vessel towards you, the displacement is taking place in the direction of force only. Suppose you have to give to your father or your mother. What you do? You push. You push towards them. in both cases, what happens here? The force makes the displacement in same direction. That is, force and displacement are same direction. Such kind of work done is called positive work done. But whenever the displacement is in the opposite direction of force, like gravitational force, that is considered negative work done. Okay. And last one is zero work done. So when there is no displacement of the body, even though you are applying a force, you are applying force on heavy objects. You know how much work you are applying, how much force you are applying, but you are unable to displace the body, then you can say that is a zero work done. Right? Now, so today we are entering into the second synopsis about energy. Energy is nothing but it is also work done only. So energy is nothing but work done, but it is capacity. Capacity to do work is called energy. So how much ability you have, how much tendency you have to do the work. For example, already I discussed in last class, when you are in study hour or END classes, teacher is given 5 questions on board as a homework, mathematics. So some of the, you have time of around 40 minutes. Some of the students completed in 30 minutes only. All the 5 questions. Some of the students completed only 3 questions in the 40 minutes. Some of the students completed only 2 questions in the 40 minutes. Or some are only 1 question. So that is their capacity. The capacity of the solving problem or capacity of doing work. That capacity is known as energy. So capacity or ability or tendency to do a work is called energy. Means energy is purely connected with the work only. They are interrelated. Right? So the unit of energy also same as work, that is joule or erg. Same as work only. So see here, often said that the person A is more needed. So if a person can do a lot of work, we say that he has the more energy or he is very energetic. We'll use the general words. In physics also, anything which is able to do work is said to possess energy. Thus, energy is the ability to do the work or capacity to do the work. So unit is same as joule, right? So if you go for commercial unit of energy, for example, if you see your electrical bill, electric energy is measured in kWh. Kilowatt hour is the largest unit of energy, electric energy. General electricity bill, that is called 1 unit. It is nothing but 1 unit. 1 kW is equal to 1 unit. When you consume 1 unit of charge, it is considered as 1 kilowatt hour. Okay, it's a commercial unit of electrical energy. So we'll come across later when you discuss about the power. Okay, so energy is nothing but capacity to do work or ability to do work, which is measured in either joule or erg. The commercial unit of electrical energy is kilowatt hour. Kilowatt hour. Right? Now, further explanation about the energies. More thing you can for the various forms of energies, various types of energies also we have. So we'll discuss. So before going for this, let me show you one video on this. So we have there are kinds of energies. Right? There are so many kinds of energies we'll use in our day-to-day life, because without energy, so we cannot do anything. Everything is depends only on the how much energy you are applying. Right? Okay, just before that, let me show you the video on the energies. Then we'll move to the next part of the energies. Right?
This video you will able to understand energy, definition of energy and different forms of energy. So let's start. First, understand the word energy. That what is energy? We know the definition of energy is the capacity to do work. It means energy is directly related to work. Now how it is related? Understand. If an object which can do more work is said to more energy compared to an object that can do less amount of work. So, energy is directly related to work. You can also understand, suppose you have to run all around a playground. Then you feel tired. More you run, more you feel tired. The reason is that a lot of energy has been spent in doing work by you. It means to do more amount of work, you need more amount of energy. Hence, we can see that there is a direct relationship between work and energy. So, energy is the capacity to do work. Now, let's discuss about the units of energy. Energy is measured in the same unit as work. Means SI unit of energy is joule. Another unit of energy is calorie. Now we understand about the different forms of energy. Students, in nature we find energy in various forms like mechanical energy, heat energy, light energy, chemical energy, sound energy, magnetic energy, electrical energy, and many more. So let's understand about all these different forms of energy. Mechanical energy. Mechanical energy of an object is the sum of potential energy and kinetic energy. In short, you can understand that the kinetic energy of an object is related to its state of motion, and the potential energy of an object is related to its state of position. In the next video, we will learn in details about the kinetic energy and the potential energy. So, mechanical energy examples that all have mechanical energy if is in a state of rest or in a state of motion, like a car in motion, arrow on a stretched bow. All these are example of mechanical energy. Next is heat energy. Now, what is heat energy? When we burn something like coal, oil or gas, then heat energy is released, and due to this energy we can do many kind of work. So the energy released when we burn anything like coal, oil and gas is known as heat energy. A very common example of heat energy is steam. Steam possesses heat energy and it is capable to do work. In common experience, you can understand that if we heat some water in a kettle with a lid on it, we notice that as the water begins to boil, the lid lift up. Why the lid lift upside? Because the steam makes the lid to lift up. This is actually the heat energy of the steam which moves the lid upside. In the same principle, James Watt in the year 1765 invented the steam engine, in which the heat energy of steam was used to do work. Light energy. Light is also a kind of energy. Without light, we cannot see any object. So light is what kind of energy? Children, the plants convert the light energy into chemical energy by the process of photosynthesis. And light energy can power the solar batteries also that we use to make electricity. So light is also a kind of energy. Chemical energy. Chemical energy, as you see in this picture, whenever you burn something, means any fuels like coal, oil and gas, it is known as the chemical energy. So chemical energy of petrol or diesel is capable to move a car or any vehicles. The food that we eat, it also possesses chemical energy and makes us do work. Means inside human body, chemical energy is there, and with the help of that energy, we can do work. Sound energy. Sound is also a kind of energy. We know how sound is produced. Sound is produced when an object vibrates. These vibrations transmit by waves that are known as the sound waves. So these sound waves carry energy, and these sound waves move through the air and come into our ear membrane. As it comes to ear membrane also vibrate, and we hear the sound of the object. But we can hear the sound when the range of the vibration, the frequency of the vibration is between 20 Hz to 20,000 Hz. This range is known as the audible range. On the other hand, some animals can hear the sound of vibrations per second above 20,000 Hz also. Magnetic energy. A magnet can attract an iron nail from a distance. It means a force is exerted by the magnet. So, this energy is known as magnetic energy. An electric motor, which is used to run a fan or other household machines, is also provided with a magnet. Electrical energy. Electrical energy is the energy we get when we use a battery, electricity supplied by the electricity board or a generator. Electric energy is used to run appliances at home, in office and other places. Electric energy can be converted into other forms of energy like sound, light, heat, etc. Atomic energy or nuclear energy. The energy stored in atoms is called atomic energy. Atomic energy is the energy released due to loss in mass when either a heavy nucleus splits into two light nuclei or two light nuclei combine to form one nucleus under certain condition. This is why atomic energy is also called nuclear energy. Atomic energy can be beneficial when it is used to generate electricity from atomic energy using atomic reactors. Atomic energy can also be used for destructive purpose when weapons like atom bombs are used in times of war. Next video is based on
Right. So it's clearly explained about the what is the energy and what are the various forms of energies will come across in our day-to-day life. So with all what we understood is whichever thing is helpful for us to do the work is called energy. Either it may be heat, or it may be sound, it may be magnet, it may be electricity, it may be atomic energy, or it may be heat energy, or it may be solar energy. All these are the used to do some work. As we are used to do the work, that is nothing but form of energy, right? So we'll see once again in details about the energies here, as you can find on the screen. So kinds of energies. What are the different kinds of energies you can see here? Already we have seen video, wonderfully explained with example. Number one, mechanical energy, where we use the muscle power or mechanical power. By using that energy, we can do the work. So without mechanical energy, we cannot do any work. Whether you want to carry your books, whether you want to lift your bottle, whether you want to move your cycle, every case you are going by two-wheeler, every case what we have to use? We have to use the mechanical energy, which is equal to kinetic and potential. That will come across later. Combination, right? Then what is kinetic energy is given? There are the mechanical energy may be either sitting at one place we can do or moving at one also we can do. By sitting at one place you can prepare chapati by applying the force. That is also a mechanical energy only. But while moving also we can do like cycle or walking or lifting a weight. So these are the two types of mechanical energies. The first one is kinetic. The energy possessed by a body when it is in motion, virtue of its motion. Every moving body, either it is a bird, flying bird, or moving car, moving train, moving vehicle, anything. Every moving body possesses kinetic energy, which is the form of mechanical energy. So that is mathematically given by the kinetic energy, mathematically given by 1/2 mv square, formula for kinetic energy. So kinetic energy is equal to half into mass into velocity square, half mv square, half mv square, where m is the mass of the body, v is the velocity. The product of mass and square of the velocity will give kinetic energy, which is the form of mechanical energy. Then potential energy. So being at position rest also, body can produce energy. By sitting at one place, we can do energy. We can produce the work. That is called potential energy. The energy possessed by a body, virtue of its position. Water in overhead tank. The energy of the spring, compressed spring. When you compress the spring and once release, it will elongate like anything, speed. Why? Because it possesses some energy. That is called potential, which is mathematically given by potential energy is equal to mgh, formula for the potential energy, formula for the kinetic energy. Very, very important formulas in this chapter, right? So, right, there is also called gravitational potential energy, because when you are lifting the body above the ground level, as you know, gravitational force acts in downward direction. In that case, you get the formula mgh. Okay, that is called gravitational potential. Both either kinetic energy or potential energy comes under mechanical energy, right? That is the one form. Now, heat energy. So, whatever the possible way of producing heat, either by burning paper, burning wood, burning coal, burning petrol, or sunlight, wherever there is a possibility of producing heat, that energy is called heat energy. With that, you can do many works. You know, you can do the heat energy in the house for the boiling the milk, boiling water, preparation of food, and geysers. So many applications are there for heat energy. So, heat energy, with heat energy, you can do some work. So, it comes under form of energy. So, heat energy is that transferred between the a system and its environments. Right? So, that is called heat energy. Next, sound energy. Sound is also a form of energy which affects our eardrums. So, how can you identify any sound? Because the sound energy reaches our eardrums and makes us to, as I told in video also, vibrations. Because you know the sound is produced by vibration of the body. During that vibration, whenever that vibration reaches our eardrums, the layer will be there in the diaphragm in the ears. That also start vibrating and making us to hear the sound. And we can do some work. With that sound only you can respond. Right? So suppose I ask some question to you. How you come to know that I asked you the question? Because the sound from my mouth reaches your eardrums and your brain will respond and you can give answer if you know the answer. Right? So that is the process where the sound energy is produced, reaches our eardrums and creates sensation of hearing. Creates the sensation of hearing. See here, beautiful forms of energies you can see in colors. Right? So there are some forms you can see here. So as already discussed, kinetic energy, which is formula half mv square. Potential energy, the formula mgh. Sound energy, so many ways you can see the sound energy. Like you are hearing the songs, either it may be mobile phones or stereos or DJ. And there are so many appliances are there where sound is produced, like guitar, veena, drums, like flute, different devices which can produce a sound energy and creates the sensation of your hearing. Then mechanical energy, already I told it may be either kinetic or potential, the energy produced by the muscles. Right? Elastic energy. You know everybody this. What is this? Catapult. You can call it as catapult. Gudel. So when you are stretching the rubber band of catapult, sorry. My mic is off, right? So radiant energy is nothing but energy produced by the radiations like sun or like okay. So sun, energy produced by sun, energy produced by bulb is called radiation energy. Chemicals also produce energy. As we are swallowing the food, it will convert into chemical energy and gives us energy for us. Okay, electrical energy is the most useful energy for us. Everywhere we cannot imagine our life without electrical energy. Then the most powerful energy in the universe is nuclear energy, which is formed by combination of small elements or dividing the large element like uranium and all. Either nuclear fission or nuclear fusion that will come across in higher classes, by which you can prepare atom bombs, hydrogen bombs, and nuclear bombs. Then heat energy. Commonly, everybody knows the heat. The energy produced by heat or the capacity of doing work by heat is called heat energy, by which you can do many works in our day-to-day life. Correct or not? So many works you can do with the heat energy. Okay. So again, various types are here. Some more types are there. Mechanical energy already we have seen. Thermal energy again comes under heat only. Thermal or heat energy. Right? Nuclear energy already we have seen. Chemical energy we have seen. Electromagnetic energy. So this is produced by electric and magnetic fields. Whenever electric and magnetic fields, they're perpendicular to each other. So there is a process called electromagnetism takes place, by which you can put the electromagnetic energy, with which you can do so many works like transformers will work on same principle, or generators works on this, electric motors works on this, where there are electric and magnetic fields together produce the energy. That's why they are called electromagnetic energy. Okay. Sonic energy, that's nothing but sound only. The waves, sonic waves produced by the sound. Sound produces some kind of waves called sonic waves. So with that waves also you can get the energy called sonic energy. Then gravitational energy, the most important, that is nature's energy. Gravitational energy means you can get the Newton, Sir Isaac Newton, who observed the gravitational force. Okay, gravitational energy, energy of the earth or energy of the planets. All the planets have energy of which attracts other bodies. So kinetic energy. So energy possessed by a moving body. Every moving body possesses the kinetic energy, which is mathematically given by half mv square. Then potential energy. So body in position. In one particular position, body can produce energy, which is called potential energy given by mgh. Ionization energy. So whenever you are removing the electron or adding the electron some process, so we'll get some energy. Release the energy. When electron is transferred from one to another, one atom to another, or received by the another atom, during those time also, ionization energy takes place, which is explained with the Bohr's model and all in your chemistry. So these are the different types of energies and forms of energies which will come across in our day-to-day life, right? So everyday life will come across all these things. All these things will come across in our day-to-day life, and we will use energies to do our work. All these energies are helpful for us to our own work, either for starting from cooking to walking, to do the work, produce the so many manufacturing, so many things. Everywhere we need the energy. To get that energy only, what we are doing, we are taking the food. Food will give energy for us, and some other things will give energy for the machines. We are all working with the energy only from morning to evening. Either it may be any form. There are various forms are there. We'll work on that only, right? Okay. So that is when you are discussing ourselves. I think already kinetic energy is given. So all the potential energy is given. So many energy forms are given. Now, there is one law is there on energy. It's called law of conservation of energy. Everybody knows the common that we can know law of conservation of energy. So all of you know that energy can be neither be created nor destroyed. Neither you can create energy nor you can destroy energy. But what happening? It is converts from one form to another form. Suppose we are filling 1 liter petrol in the vehicle. When you travel 40 kilometers or 50 kilometers, petrol will be over. It doesn't mean that petrol is wasted. That petrol heat energy is converted into mechanical and you can able to cover the some distance. You are doing some work with that. It is not wasted. So like that, there is a transformation of energies. Energy will transform. Energy is not wasted. It transforms to another form. That is called law of conservation of energy, which we'll discuss tomorrow. So energy is neither be created nor destroyed. It may transform from one form to another form, or it may change from one form to another form. Suppose we are switch on the current. Electric energy is used to run the bulb, used to run the fan. We'll get the bill by end of the month. It doesn't mean that we are wasting electricity. We are using them for some purpose. We are using to cool our objects. We are using the cooling the room. We are using for the geyser purpose. We are using for the other purpose. Thing is, the energy is converting to one to another form. That's all. It is not wasting. Such a method is called, the law is called law of conservation of energy. So you can see that how it takes place for the body which is coming down or body which is vertically thrown. We can prove that the energy, stored energy in the system is constant, even for the oscillating pendulum. 3 cases we have discussed, which we'll do in the next class, followed by the so many other forms of energies, how they are converting. Okay. And finally, we close with the power part. Okay. So this is your home task today. Define energy, mention types of energies. There are 10 to 15 energy forms are there. Even you can prepare the chart also with pictures, what I corrected like that. And you can paste in your classroom as a project work, weekend project. All the forms of energies and their applications you can mention. Okay. So note down the question here and write in your notebook homework and take the signature from parents and your subject teacher. Right? So that's all for today. So have a wonderful day. Thank you, all of you. Thank you.